Hi everyone, welcome to this example of the application of Kirchhoff's rules to a DC circuit. So in this example says for the circuit below, write down the equations for Kirchhoff junction rule at the two junctions J1 and J2. So a junction is simply a point in the circuit where two or more wires are connected. So this circuit has two junctions labeled J1 and J2. So for the first junction, immediately we can see that I2 is going into the junction. I1 is flowing out of the junction all the way around. I3 is also flowing out of this junction all the way around and then combines with I1 to form I2. Therefore, for junction number 1, Kirchhoff's rule is I2 equals I1 plus I2. Now for the second junction, which is here, the currents going into the junction are I1 and I2. And then I1 and I3. I2 is going out of the junction. Therefore, the junction rule, we say is sum of current in equals sum of current out, could be written as follows: I1 plus I3 equals I2. Note that both equations are the same, so technically it doesn't matter in this circuit which junction you apply the junction rule to, because you end up with the same equation. Next, we're going to look at how to apply the loop rule to this same circuit. Okay, so for the circuit shown, write down the equations for Kirchhoff's loop rule for loops 1 and 2. So this is the circuit up here, and loop 1 starts from the junction J2 and goes all the way around, okay, back to J2. Loop number 2 starts at J2 and goes all the way around back to J2. So for loop number 1, again, the first step is to identify the elements, the circuit elements that are traversed as you go in the direction of the given loop. So for loop number 1, as we go starting from J2, we're going to traverse the 1 ohm resistor. We're going to traverse the 2 volt battery. We're going to traverse the 2 ohm resistor and then the 4 ohm battery, and we're back to J2. For loop number 2, starting from J2, we're going to traverse the 4 volt battery, the 2 ohm resistor, the 1 ohm resistor, 6 volt battery, and the 3 ohm resistor, and we're back to J2. Therefore, the loop equation for loop number 1, so starting from J2, going clockwise, we're traversing the 1 ohm resistor in the direction opposite the current. Therefore, we're going in the direction of increasing potential, and the potential difference is plus I1 times 1 ohm. The next element is the battery, the 2 volt battery, and we going in the direction of high to low. So we're going in the direction of decreasing potential. Therefore, we have minus 2 volts. The next element is the 2 ohm resistor, and following the loop, we're going in the direction opposite the current. Again, we're going in the direction of increasing potential. Therefore, the potential difference is plus I2 times 2 ohms. And finally, we traverse the 4-volt battery from low to high, direction of increasing potential. So that gives us plus 4 volts, and then everything equals 0. For loop number 2, starting from the junction, J2 going in the direction of the arrow, we traverse the 4-volt battery in the direction high to low, decreasing potential, so minus 4 volts. And then we traverse the 2 ohm resistor in the same direction as the current, so in the direction of decreasing potential, so minus I2 times 2 ohms. And then we traverse the 1 ohm resistor in the direction of decreasing potential, because I3 goes the same direction as the loop, so minus I3 times 1. Then we traverse the 6-volt battery from low to high, so plus 6. And then we traverse the 3 ohm resistor in the same direction as the current I3, so minus I3 times 3 ohms, and everything equals 0.